Good day, this is General Mathematics 1, MTH 101. I'll be taking you study section 8, trigonometric identities. After you have studied this section, you should be able to use the concept of trigonometry in solving practical problems as it applies to elevation and depression and triangles. Secondly, you should be able to state some trigonometric identities. First of all, let us derive some formula as you have been introduced in previous study sections to arrive to some certain trigonometric functions. For example, let's consider a triangle OAB. Alright, considering triangle AOB, as you can see on the slide, theta is the angle which is facing the hypotenuse, which is facing the opposite side, which is y, while the hypotenuse side is the r, and the adjacent side is the x. Now we want to show one trigonometric identity. We want to prove that our s squared theta plus cos squared theta is equal to 1. Now let's start from sin theta, as you have been introducing. Now let's start from sin theta. From other study sections, we have been introduced to the mathematical expression for sin theta considering a right angle triangle. Sin theta is equal to opposite over hypotenuse, which is y over r, whereby our cos theta is equal to adjacent, which is x, over hypotenuse, which is our r. Now, but before we proceed, we must be able to derive an expression for the hypotenuse side, which is r squared is equal to the opposite side, which is y squared, and the adjacent side, which is our x squared. Now we can also derive an expression for sin theta and cos theta by multiplying sin theta by sin theta to give us sin squared theta. If we multiply sin theta by sin theta, we derive an expression which is sin squared theta and is equal to y squared over r squared. Similarly, we can derive an expression for cos theta by multiplying cos theta by cos theta in order to derive to have an expression for cos theta, and it's going to give us cos squared theta is equal to our adjacent, which is s squared over our hypotenuse r squared. Now substituting this expression into this expression, we derive another. Okay, from the expression r squared is equal to x squared over y squared, we can derive our formula by substituting for x and y from these following expressions. Then our r squared is equal to, when we make x squared the subject of formula here, we are going to arrive at r squared cos squared theta. And similarly, if we make y the subject of formula here, we are going to arrive at r squared sin squared theta. Now, dividing this equation by r squared, we obtain an expression for cos squared theta and sin squared theta, which is r squared divided by r squared is equal to r squared cos square theta over r squared plus r squared sine square theta over r squared. We can eliminate r squared and arrive at an expression that our sine square theta plus cos square theta is equal to 1. Now let's go back to the slide, and that is the expression we have shown here. Applying Pythagoras theorem, we have x squared plus y squared is equal to r squared, and dividing by r squared, we obtain an expression, and we substitute using our SOHCAHTOA, sin theta and cos theta, in order to arrive at an expression which is sin theta sine square theta plus cos square theta is equal to 1. We can also derive some other expressions from as we have obtained that sine square theta plus cos square theta is equal to 1. We can also derive an expression for sine square theta and cos square theta by making them the subject of the formula respectively. Sine square theta can be written as 1 minus cos square theta. That's an expression, that is trigonometric identity, another trigonometric identity that we can obtain from this first expression. We can also obtain another expression, cos theta is equal to 1 minus sine square theta. So far we have obtained 3 expressions for our trigonometric identities. So let's proceed. We can also proceed to derive more expressions for our trigonometric identities. Let's move ahead as we. Now, so far we have derived about 3 formulas. We want to continue to see other identities that we can obtain from the first expression. We have cos square theta plus sine square theta is equal to 1. Dividing through by cos square theta, we have cos square theta divided by cos square theta divided by cos square theta. Now, through this expression, we can eliminate cos square theta to have an identity which is sine square theta of cos sine square theta over cos square theta is equal to 1 over cos square theta. Remember that in the previous study sections, we have been introduced to sine square theta over cos square theta, which is going to give you sec square theta. Sec square theta, sec theta is equal to 1 over cos theta. Therefore, we can substitute, and this is the same thing as you can write this as sec. Alright, so if you square, if you multiply sec theta by sec theta, you obtain an expression for sec square theta. Similarly, you can derive another expression. You can derive another expression from. You can see that this expression is very, very important where trigonometric identities are concerned. You can also divide through by sine square theta to obtain an expression. Divide by sine square theta. Now, you can eliminate this out to give cos square theta all over sine square theta. Give you over what? Will give you 1 over sine square theta. And similarly, you know that sine cos. So you remember that cos square theta over sine square theta will give you a cos sec square theta plus 1 is equal to 1 over sine square theta. Making cos. So through the expression, making cos sec square theta the subject of the formula, you can derive an expression for cos sec theta, which is 1 over sine square theta minus 1. So the expression is written here. As you can see, 1 over cos sec square theta is what gives you your tan square theta, as you can see. And you can derive other expressions for other trigonometric identities. You can use the knowledge of what you just did now in other trigonometric problems, like what you're seeing on the slide. 1 over 1 minus sin theta plus 1 over 1 plus sin theta will give you 2 sec square theta. What you need to do is to take the LCM of the left hand side of your expression. After taking the LCM, you factorize in order to derive an expression for the problem you are solving, and at the end of the day, you will arrive at 2 all over 1 minus sine square theta. And remember that if you do some little arithmetic manipulations, you'll be able to arrive at 2 over cos square theta, and 1 over cos 2 over cos square theta. You get another expression, which is your last expression for the problem. Similarly, you can also prove this trigonometric problem, as you can see on the slide. Cos theta divided by 1 plus sin theta is equal to 1 minus sin theta all over cos theta. In this type of arithmetic problem, what you need to do is to substitute and make some manipulations in order to arrive at the required solution. What you will do here is to substitute for cos theta. To multiply both sides by cos theta in order to arrive at an expression which gives 1 minus sin theta cos theta all over cos square theta. And remember that cos square theta is equal to 1 minus sin square theta. So what you will do is to substitute for cos square theta. Now, substituting for cos square theta, you have another expression which is sin 1 minus sin theta into bracket cos theta all over 1 minus sin square theta. And when you do a little mathematical algebra manipulation, you know that 1 minus sin square theta is equal to 1 plus sin theta into bracket 1 minus sin theta. So you are going to arrive at an expression which gives you 1 minus sin theta into bracket 1 plus sin theta. If you factorize this expression, you get your 1 minus sin theta back. So you can easily eliminate 1 minus sin square theta, and you will have cos theta plus 1
of sine theta.
Continue with simple algebraic manipulation, you'll be able to arrive at your final solution. Similarly, you can also proceed to solve this simple problem. You can simplify sine squared theta divided by 1 minus cos squared theta. All you need to do here is to substitute for the denominator. And we know that 1 minus cos squared theta is equal to sine squared theta. And that was what was done, as you can see on the slide, to arrive at your 1. Example 4 also, you can substitute for your cot theta, because cot theta is equal to 1 over tan theta. And you divide tan theta over 1 divided by tan theta to get your sec theta, which is bracket sec theta minus tan squared theta. And following all the expressions, you'll be able to arrive at your final solution, which is 1. Having undergone all these trigonometric proofs, you will be able to come to a conclusion of some trigonometric identities, like that of cosec theta, which will have 1 over sin theta, sec theta, 1 over cos theta, and so on and so forth. And this is the end of study section 8. Thanks for listening.